Many early computers used purely mechanical digital-to-analog converters because, of course, they didn't have a reliable electronic way to do the conversion. Some were based on a device called a Whiffletree, or sometimes a Whippletree. This is one from an IBM Selectric typewriter, a purely electromechanical device as opposed to an electronic one. The Selectric Whiffletree encodes some 7 bits of information, but to see how one works, let's look at the simplest converter, one that encodes 2 bits of information. A Whiffletree consists of rigid metal bars which are joined with pivots. What it does is the following. It converts a uniform pole on the vertical yellow tabs to 4 different positions of this blue bar. At the end of the blue bar might be a printhead, for example, that has 4 different characters on it. The key idea here is that you use the same magnitude of pole on the tabs every time. That's the digital part. Either you have an impulse or you don't. Let's look in detail at how this moves the blue bar to 4 different heights. That'll take 2 bits of information. For that, you need to place the blue bar such that it's 1/3 of the horizontal bar's length from the left and obviously 2/3 from the right. The first bit is obvious. It's just 0, 0. You don't move the printhead at all, and that's position 0. To encode bits at 0, 1, you keep this pivot fixed and pull this tab with a stroke of length S, say. You move the blue bar a distance of 1/3 S. You can determine that using similar triangles. We'll call the distance the blue bar moved D. That's position 1. To encode bits 1, 0, keep the right pivot fixed and pull on the left tab. You can again find the distance that blue bar moved using similar triangles. It's 2/3 of the stroke length S, or in our notation, 2D. We'll call that position 2. To encode bits 1, 1, pull both tabs a distance S and you'll move the blue bar by S units, or 3D. And that's position 3. So now you can see how we convert the binary impulse of the tabs, either nothing or a pull of length S, to a regular motion of the blue bar in steps of distance D.